Right now, as we speak, these secret mathematical models are making huge decisions about your life. We're talking what job you might get, how much you pay for insurance, even, and this is crazy, how long you might spend in prison. They're invisible, they're incredibly powerful, and as we're about to find out, they can be really, really destructive. We all have this idea that math is, pure, it's objective. A machine running an algorithm can't be biased, right? Well, this quote about Kathy O'Neill, the author of our source material, really just hits the nail on the head. It perfectly captures the myth we're going to be tackling today, this idea that algorithms are always impartial. So, the big question I have for you is this. Are these secret formulas already running your life? The scary answer is almost certainly, yeah. So let's pull back the curtain and see exactly how this all works. Okay, here's our game plan. First, we're going to define what a weapon of math destruction actually is. Then, we'll dive into two really powerful examples, the college rankings game and predictive policing. After that, we'll pull it all together to see what this says about the cost of efficiency. And finally, we'll look ahead to our algorithmic future. All right, section 1. What exactly is a WMD? Let's get a really clear definition of this new kind of threat. So Kathy O'Neill came up with this brilliant term, a weapon of math destruction, or WMD for short. And look, it's not just any old algorithm. It has to be widespread, it has to cause real damage, and, this is the most important part, it has to create a destructive feedback loop. Let's break that down into 3 key ingredients. First, you've got scale. It has to affect a ton of people. Second, damage. It's got to be actively harming them or putting them at a disadvantage. And third, the feedback loop. This is the real kicker. It creates this vicious cycle where the model's own bad results just get fed back in, proving it's right and making things even worse. Remember these 3 things. They're going to be our guide for the rest of this. So, section 2, the college ranking game. Our first case study is a wild one. It's about how a simple magazine feature accidentally created a WMD that kicked off a full-blown arms race in higher education. It started out pretty harmlessly. Back in 1983, the U.S. News and World Report rankings were just based on opinion surveys. But then, in 1988, they rolled out a data-driven model. Fast forward to the 2010s, and this thing isn't just a feature in a magazine anymore. It's a titan. It's the undisputed standard that has the entire education system tied up in knots. So, how in the world did this model try to measure something as vague as excellence? Well, you can't really put a number on personal growth, right? So instead, they use proxies, basically stand-ins for quality. Things like SAT scores, acceptance rates, how much alumni donate. And on the surface, that all sounds pretty reasonable, doesn't it? But here's the twist. The model's catastrophic failure wasn't about what it measured. It was about the one huge, massive thing it chose to completely ignore. And this slide just lays it all out. The model measured things that signaled prestige. It rewarded schools for being super exclusive and having students with high test scores. But what did it ignore? Student cost, tuition, fees, debt. None of it was in the equation. So the message it sent to colleges was clear. Getting more expensive won't hurt your rank. In fact, spending more might actually help you climb. And the damage from that? Get this. A 500% increase in the cost of college in just under 30 years. That is the feedback loop right there, in action. A higher ranking meant you needed to spend more on fancy buildings and marketing, which meant you had to charge higher tuition, which, you guessed it, funded even more spending to chase an even higher rank. Okay, let's look at a real-world example. Texas Christian University, or TCU, was falling in the rankings. So what they do? They went all in. They launched a huge fundraising campaign, built amazing sports facilities, and just poured money into their football program. They decided to play the game by the model's rules. And guess what? It worked. Big time. TCU shot up 37 places in only 7 years. They had successfully gamed the WMD. But by doing that, they just reinforced the very system that forces every other college into this insane, expensive arms race and leaves students and their families holding the bag. All right, section 3, policing by prediction. Let's shift gears to our next case study, because here the stakes get even higher. We're talking about software that tells police where to patrol and how it ends up creating a feedback loop that pretty much criminalizes poverty. Now, to understand this, you have to look at the data being fed into the model, and there's a really important difference here. You've got Part 1 crimes. These are serious things like homicide that people actually call 911 to report. Then you have Part 2 crimes. These are nuisance offenses, stuff like loitering or public drinking, that only get recorded if a cop is literally standing there to see it happen. And here it is, that destructive feedback loop in plain sight. It starts with data on those nuisance crimes, which are often concentrated in poorer neighborhoods. That data goes into the model. The model then flags those areas as hotspots and sends more police there. Well, what happens when you have more police on the streets? You get more arrests for, you guessed it, nuisance crimes. And that new data gets fed right back into the model, which sees it as proof that it was right all along. It's a perfect, toxic, self-reinforcing cycle. So here's the most crucial point of all. The algorithm itself doesn't see race. It can't. It just sees zip codes and street corners. But as Kathy O'Neill puts it so perfectly here, in our largely segregated cities, geography is a highly effective proxy for race. So the model, even if it's meant to be colorblind, becomes a tool for biased policing. And the real-world damage of this kind of thinking is it's stark. Look at the numbers from New York's controversial stop-and-frisk policy, which was kind of like a human version of this logic. An absolutely staggering 85% of the people stopped were Black and Latino men. This is what happens when a system focuses its attention on specific neighborhoods. It ends up focusing that attention on specific people. Okay, Section 4, the price of efficiency. So what do these two stories, colleges and cops, really tell us? Well, they show this fundamental conflict. In this relentless hunt for algorithmic efficiency, fairness is almost always the first casualty. I absolutely love this analogy from O'Neill. It's so powerful. Think of a WMD as a factory. The product it's churning out might be efficiency or crime prediction. But the unfairness, that's the black smoke pouring out of the smokestacks. It's an inevitable toxic emission from the whole process. And this slide just shows the complete misuse of data perfectly. Look, both Amazon and the justice system are obsessed with recidivism, with people returning, but their goals are total opposites. Amazon uses its massive amounts of data to constantly test, learn, and improve its system to encourage you to come back and buy more stuff. The justice system, on the other hand, uses its data mostly to justify what it's already doing, without ever seriously asking if things like longer prison sentences actually work to prevent recidivism. It doesn't learn, it just confirms its own biases over and over again. Which brings us to our final section, our algorithmic future. This all leads to one final, really critical question for every single one of us living in this data-driven world. The weapons of mass destruction we looked at today, in college admissions and in policing, they're just two examples. But these things are everywhere. They're in hiring, in loan applications, in insurance. So the question I really want to leave you with is this. What hidden algorithms are making decisions about you right now? What invisible formulas are shaping your opportunities, and what can we do to finally drag them out into the light?